Hello and welcome to Expert Insight. Today we are speaking with Quentin Ochem, Chief Product and Revenue Officer for AdaCore, about ensuring software safety in the automotive industry. And we're going to get right into the technical details. Quentin, what can you tell me about these recalls that are going on? There were over 2 million vehicle recalls in the US last year, in part because vehicles have become so complex. Can you briefly explain ISO 26262, it's one of the subjects we want to talk about today, and why international standards like that one and others can help OEMs avoid recalls?
So you have to realize the amount of software that is in the car nowadays and the amount of things that this software is doing. I mean, to a large extent, cars are more complex than planes from a software standpoint, right? You have hidden software that is managing all of the function of the car, the so-called assistance driving. So, when you drive and your car knows when to slow down and maybe to stop, assist you when you turn, complains when you're passing a lane without putting your blinker on. All of these things, there's massive amount of software. This is just like the tip of the iceberg. We're talking million lines of code that are intertwined and interconnected, sometimes even with exposure on the outside, which open them to cybersecurity threats. So it's extremely easy to make little mistakes in those million lines of code, and little mistakes can have very, very significant consequences. There's a very famous case that dates for maybe 15 years ago, which was a Toyota system that was accelerating the vehicle without the intention of the driver, and that resulted in accidents. So that's an extreme case, but you can have an array of things. And typically, when errors on software are detected, then they lead to updates. But of course, your car is not like your Windows machine, right? If you need an update, you don't want that update to happen while you're driving or when you don't know about it. So that needs to be done in the context of a recall, where the manufacturer will do an actual patch on your vehicle. And this is, of course, very, very expensive. And this is additive to all of the other reasons why you might have recall, for example, mechanical reasons and so on and so forth. It is not a new issue. The software industry at large has had to face those issues in other places in the past. I was talking about avionics. This is something that has been looked at since the 1890s. And the one way to mitigate those issues is so-called safety certification processes. So for automotive, we talk about the ISO 26262. And what the ISO does is that it describes 4 categories of software, if you will, depending on how impactful a failure could be. And it describes what you should do to minimize the risk of error, to minimize the possibility of a software mistake that would find its way to production and then cause a potential harm. But the other thing that you need to consider is that the industry is highly fragmented. So you have a lot of manufacturers, and they have their tier ones and tier two and so on and so forth, which provide components. So you need some way to homogenize this entire environment, right? If I'm Toyota, how do I make sure that who is providing my steering wheel is providing that steering wheel with software that I can trust? And the ISO 26262 is the answer that the industry has adopted.
Well, yeah, that's exactly the topic I wanted to get to. Right now, OEMs like Toyota, like whoever, they interact with suppliers and had require them to adhere to these various standards. What is the best way for the OEMs to discuss these requirements with their suppliers and sort of get them on board with needing to, like you said, make sure the steering wheel is going to do exactly what it should?
So there's 2 aspects, right? One aspect is the requirements, and there's no magic there. You need to have providers that need to be very precise in what do they expect, what is the anticipated behavior and so on and so forth. But then once you establish that, how do you ensure that it has been properly implemented? And that's where you sort of have the magic answer of the safety standard, the ISO standard, say thou shall respect the standard. And then you are going to use independent assessors to verify that the standard has been respected. This is the work of TÜV, for example, which is one of the few assessors that are trusted into doing that. That doesn't provide all the answers that you want. I mean, as the integrator, you will still need to integrate, verify things in context of the entire vehicle and so on and so forth. But that does raise significantly the trust that you have in the software and the system that is being delivered to you.
You kind of hinted at it there a little bit, but some of these complex systems, one of the possible solutions to get everyone talking on the same page is a better formal verification of this software, especially when it comes to the overarching frameworks that are involved here. Can you talk about that a little bit, how developers can use these verification systems to increase the reliability and security of their systems?
Yes, absolutely. So if you step back, of course, when you look at the ISO 26262, a big part of it is verification. And you have the traditional methods of verification that combines a lot of testing and then what we call static analysis, which is about looking at the code and trying to find possible errors. But there's another way that you can go about for this thing, which is, as you just mentioned, formal methods, right? And the idea behind formal methods is that you're going to describe properties on the software. You cannot, unfortunately, describe everything, but there's a number of things that you can describe. And you're going to have a mathematical method to demonstrate that this property holds within the entire application. So if I give you a simple example, you may say something like, there's going to be a bit technical, but you might have heard of this buffer overflow, which is a very common issue. And normally, to mitigate the odds of a buffer overflow, you would use a combination of testing, static analysis, fuzzing, and so on and so forth. But with formal methods, you can describe that property very easily. My software should not have buffer overflow. And then you're going to have a mathematical demonstration that in all possible cases, no buffer overflow can possibly happen. And that's a very simple property. You can describe more complex properties. You can define part of your requirements in terms of formal methods for analysis. Now, I want to contrast what it means to look at this requirement or properties from the traditional angle and the formal method angles. You use traditional methodologies. You will always be able to demonstrate that for a number of cases, those that you could look at, your software is okay. But you cannot say this error is not possible at all, whilst when you use formal method, it's kind of a bulletproof demonstration, if you will. This class of problem does not exist.
When you talk about different coding languages and things to sort of get into these solutions, do any of them stand up? I mean, I feel like I've heard Spark mentioned as a coding language that's particularly well suited.
Yeah, that's an interesting question. It's in order to achieve that, you need a formalism that is fit, that has been designed with this idea of safety, of reliability, of formalism in mind. And there aren't that many languages that have been built for that. As a matter of fact, this formal method idea, usually they lead to extensions to existing languages, often in the form of comments, which is sort of adding a layer of complexity, and the connection is not easy. So it's been hard to deploy those methodology in, I would say, outside of the research lab in an industrial context. Now, Spark is interesting because Spark is an evolution of a language that is called Ada that was developed in the early 80s with really this idea to specify as much as possible in software to let the compiler verify things or generate checks and so on and so forth. And it turns out that all of these ideas that we developed in the 80s lend themselves particularly well to the need of formal methods because all of the information is there already. So indeed, today, I would go as far as saying that the only programming language that allows you to deploy formal methods at the level of the programmer, right? There are many other places where you may want to do that. But for programming's sake, today Spark is really the only language that allows you to do that at scale in industrial context.
Well, that's one reason why it keeps coming up in these sort of discussions. I know as we evolve, or as the industry evolves and these challenges keep coming up, maybe that'll be the solution next time. Maybe it'll be another thing. But for today, that's a great insight from our expert, Quentin Ochem, Chief Product and Revenue Officer at AdaCore. Quentin, thank you so much for joining us today.
Thank you.